Now let's try to solve this so-called three-horsemen problem, right? If I remember correctly, you have a equilateral triangle, right? So the three sides of the triangle are identical. So, and then the three angles are all 60 degrees, right? So A, B, and C is an equilateral triangle, and the side length is 4, right? And inside of this equilateral triangle, you have another smaller triangle made up by the 3 points D, E, and F, right? Um, and then D, E, and F are three horsemen who's gonna move around, right? D is only gonna move along AB, right? So D could actually move around um, along AB. E can move around along AC, and then F can move around along BC. So these 3 points can change, right? But they can only be changed. They can only change along the restrictions made by the sides of the equilateral triangle. The question is that you have to find the minimum of the perimeter of this inside triangle, right? So what's the minimum of DE plus EF plus DF, right? So how do we solve this problem? Usually, these kind of geometrical problems can be solved by resorting to our basic understanding on a two-dimensional plane. The shortest distance between 2 points is actually a straight line, right? So can we actually use that results somehow in solving this particular problem, right? So let's try to actually convert the perimeter of this triangle into somehow some kind of line, right? How can we actually convert the perimeter into like a one line? We can do this. We can do this. Suppose we make a image symmetric point of F along AB, right? Suppose we do this, right? So this is going to be a right angle, okay? And then we're going to extend it. We're going to extend it, right? And this is the mirror image. This point is going to be the mirror image of F, and the symmetry axis is going to be AB, right? And then we're going to call this point F prime, right? And then we can connect F prime and D, right? So now DF becomes DF prime, right? Because it's symmetric. So DF becomes DF prime, right? So we have moved this side to DF prime, to this side, right? And then we can try to do the same thing. Make a mirror image of the point F with respect to the axis AC, right? So again, we can actually try to draw a vertical line, right? So this is going to be symmetric, vertical, right? And then extend it, right? You have to extend it, and then we're going to call this point F double prime, right? And then we can actually connect E and F prime, right? So at this point, I have transferred this axis EF, this line, this edge, to EF prime, E double F prime, right? So this edge is going to be the same as this edge, right? So now the perimeter of this inner triangle is going to be identical to F prime plus F prime D plus DE plus EF double prime, right? So now we can try to actually make F prime F double prime into a straight line, right? If we want to make this thing smallest, then it's going to be a straight line, right? So F prime F double prime is going to be a straight line. Let's just connect F prime and F double prime, right? So F prime F double prime is going to be a straight line that connects F prime and F double prime, right? So that's going to be a straight line. And then we're going to try to actually find under what conditions F prime and F double prime is going to be minimal, right? And at the same time, we're going to also connect A and F prime. and also A and F double prime. Right. Okay, so now let's try to solve it. Right, let's try to solve it. Suppose let's focus on this triangle AF prime and F double prime, right? And suppose we connect A and F. Right. So we'll connect A and F. Right. And because we know F and F prime are symmetric to each other with respect to AB, right? So we know this angle equals to this angle, right? And we know, because we know that F and F double prime are symmetrical with respect to AC, so this angle equals to this angle, right? So what, say, suppose this angle is angle 1 and this angle is angle 2, right? And this is 2 also, this is 2 also, this is 1 also, right? So we know that this is an equilateral triangle, so 1 plus 2 equals to 60 degrees, right? So 1 plus 2 equals to 60 degrees, right? And the same is true about this one and this two, right? So this angle F prime A F double prime is gonna be 2 times 60 degrees, right? So the angle F prime A F double prime is gonna be equal to 60 degrees times 2. It's gonna be 120 degrees, right? And then now let's look at this edge, right? This and this edge, right? Because AF prime is gonna equal to AF, right? Because F prime and F are symmetrical with respect to each other, right? So, and the symmetric axis is AB, so AF prime is gonna equal to AF, right? And also it is true from here, right? So AF also equals to AF double prime, right? So AF prime equals to AF equals to AF double prime, right? Because of the symmetry. F and F double prime, F and F prime, right? So it means what? It means AF prime equals to F double prime. So these two edges are actually identical, right? So this angle is 120 degrees, and this edge are identical to each other. So let's say the length of this edge is going to be x, right? And so the length of this axis is also going to be x, and we know this is 120 degrees, right? F prime A F double prime is 120 degrees, right? So we have a triangle, right, that looks like that. So this is A, this is F prime, this is F double prime, right? And this is 120 degrees. This edge is x, this edge is x, right? So what's going to be F prime F double prime, right? So if we divide it in the middle, so this is the middle point, right? And this is going to be a right angle triangle, right? So this is going to be 60 degrees, right? So the height is going to be what? So this is going to be 30 degrees, right? So the height is x over 2, and then this length is going to be x square root of 3 over 2, right? That's going to be this length, right? And then this length is going to be the same, right? This is also going to be x square root of 3 divided by 2, right? So add them together, you get square root of 3 times x, right? So F prime F double prime, so F prime F double prime equals to square root of 3 times x, right? So now we got an expression for the F prime and F double prime, right? And don't forget that F prime and F double prime should equal to the perimeter of this inner triangle, right? So how do we actually make square root of x, square root of 3 times x smallest, right? And don't forget, x also equals to what? X also equals to AF, right? So AF also equals to x, right? AF also equals to x, right? So these three sides are all equal to each other. So AF also equals to x, right? So when f prime and f double prime is the smallest, means what? Means x has to be the smallest. Don't forget that the point f can only move along BC, right? It cannot move anywhere. It can only move along BC. So what's going to be the smallest x for AF, right? The smallest x is found when AF is perpendicular to BC, right? So we have to draw a vertical line so that this is a right angle triangle. It's 90 degrees, right? So what's in this case, what's going to be the smallest x, right? Don't forget this equilateral triangle has a side length of 4, right? So this is AB is 4, AC is 4, right? And this is going to be 30 degrees. This is because this is 60 degrees. This is 30 degrees, right? So this is going to be 4, right? And then this base of the right angle triangle is going to be 2, right? This is going to be in the middle. So this point is let's call this point G, right? Let's call it. So BG is going to equal to 2, right? So BG is going to equal to 2, right? The minimum when x is smallest, x is minimum, right? So BG is going to equal to 2, and then x is going to equal to what? X is going to be 2 times the square root of 3, right? So x min, the minimum of x is going to equal to 2 times square root of 3, right? So AG has a minimum of 2 times the square root of 3. So what's going to be the minimum of f prime and f double prime, right? So the minimum is going to be 2 times square root of 3 times square root of 3, right? That's going to be like 6, right? So the minimum value for the parameter of this triangle is 6.